What if the basic linear algebra subprograms, the BLAS, are not parallelized? But they are, you say. Well, they are for real and complex floating point numbers. But what if you're using a computer algebra system and doing linear algebra in some other ring? What if you want to do lengthy computations using vectors and matrices and polynomials, for example, and you want to take advantage of your multi-core machine? In this case, you can imitate the multi-threaded BLAS. Timing tests can guide your parallelization efforts. Let's take 3 example routines, one from each level, and implement a straightforward parallelism using par4 and pari. Because of the simplicity of this approach, all 3 routines can be written as one-liners if desired. Here they are, highlighted in their basic form and their parallel form. Here we see the level 1 AXB, vector plus vector, the level 2 GEMV, matrix times vector plus vector, and GEMM, matrix times matrix plus vector. Here they are in the parallel form. The parallelism is done very straightforwardly. Here in par GEMV, it's split by row time column, and par4 then allocates each of those computations to a different thread. But have we made it faster? Let's try 2 data types, real and integer polynomial. Let's first test pari's real number implementation, which is more involved than simply a raw floating point value. Based on episode 10, you would expect the parallel version par AXB with 24 threads to be slower than AXB, and you would be right. But what about the others? Here we see AXB and par AXB with a test for 24 threads, GEMV and par GEMV, and GEMM and par GEMM. These are run, and the only parallel version which beats the serial version is GEMM, but it beats it by a good amount, 7.4 times. We move from real vector entries, which exercises the floating point unit, to 9th degree integer polynomial entries, which should exercise both p-cores and e-cores, and so should benefit more from the higher thread count. Here we see the results. In this case, GEMV is 3.8 times faster with 24 threads, and GEMM is 10.7 times faster with 24 threads. That's all for now.